Hello ladies and gents, welcome to this DesignBuilder webinar focusing on our latest lifecycle analysis or LCA tools and our integration with One Click LCA. I'm Dave Cocking and with me is Andy Tyndale from DesignBuilder. We'll also be joined today by Panu Pasanan, an LCA, LCC, embodied carbon and sustainable performance expert, and the CEO at Bionova and One Click LCA. One Click LCA accesses the largest LCA database on the market, allowing modelers to quickly quantify and report LCA compliance with schemes such as BREEAM and LEED, and to provide reports to meet more general regulatory and corporate social responsibility requirements. I'll leave it to Panu to provide the detail on all of this later. DesignBuilder and One Click LCA have both been developed with ease of use and modeler productivity in mind. So it's no surprise that they work together seamlessly to allow building carbon footprints and other environmental impacts to be assessed and reported in literally just a few minutes. Our native integration with One Click LCA means it can be accessed directly from the toolbar within your DesignBuilder model. This webinar will show you how to leverage the workflow between these two easy-to-use tools, enabling you to automate lifecycle assessment, lifecycle costing and embodied carbon calculations from your energy model and make light work of lifecycle analysis. We'll start today's webinar with a brief introduction to lifecycle analysis for those that are unfamiliar with it, and we'll then review a recent small office project model in DesignBuilder. After reviewing some of the LCA specific model data, such as constructions, we'll hand over to Panu, who will talk you through the One Click LCA aspects in much more detail. You can submit questions at any point during the webinar via the questions box in the control panel. We have allocated time at the end to answer as many questions as we can, so we expect the webinar to last around about an hour. It is being recorded, so you can access it later if required. Before we dive into the details of LCA, let's take a look at the underlying reasons for LCA modelling. Many of you will, of course, be interested in the business and educational opportunities that LCA offers as an additional strand of building simulation, and I will come back to that. But I'm going to start by considering the environmental imperative. Rather than simply mentioning climate change in a kind of abstract way, let's take a look at some specifics. The recent UK 2018 Climate Projections report provided some sobering information regarding likely future weather conditions in the UK. The study predicted that high emission carbon scenarios could result in average UK summer temperatures being over 5 degrees C warmer in 2070 than they were in the period 1981 to 2000. It also predicts summer rainfall in 2070 could be around 50% of 2000 levels, with much larger swings between summer and winter rainfall, causing problems like flooding events. Whilst these figures relate to the UK, climate change is, of course, a global phenomenon, with serious heatwave conditions reported across Europe, in the US and Japan, and many other countries in 2018. Major international news stories related to climate change now seem to be a weekly occurrence. In just the last few weeks, we've seen wildfires raging in parched areas of California, and earlier this week, we saw unprecedented flash flooding in Sydney, Australia. The intensity and frequency of these kinds of events are predicted to increase significantly. The fourth US National Climate Assessment, released recently, gives many specific examples, such as overwhelmed dams in South Carolina, failing crops in the parched Great Plains, and a rise in insect-borne disease in Florida. The report also warns about the economic impact, such as the effects on crumbling infrastructure, falling crop yields, and decreasing labour productivity, all of which will soon percolate into every corner of American life. A report released this October by the Intergovernmental Panel on Climate Change said if we fail to act, there would be some significant and dangerous changes to our world, including rising sea levels, significant impacts on ocean temperatures and acidity, and a reduced ability to grow staple crops such as rice, maize, and wheat. The negative impacts on mortality and agriculture from such large changes over such a short timescale are dramatic. Life cycle assessment as part of holistic sustainable design is being increasingly recognised as a way of contributing towards mitigating all of that. The vision of many governments and major institutions is for the population to live and work in carbon neutral buildings that literally don't cost the earth to build or to operate. This becomes increasingly important when you consider that the global population is expected to double in the next 40 years, massively increasing the number of additional buildings required to live and to work in. The good news is that our industry and you as individuals have the knowledge, skills and tools to help push things in the right direction. I'll now very briefly introduce the concept of life cycle assessment for those of you not yet familiar with it. A life cycle assessment provides a cradle to grave analysis of the impact of a manufactured product on the environment. In the context of the built environment, this comprises everything that you need to construct and operate the building, from raw materials through to demolition and disposal of building components. The main stages analysed as part of a full life cycle assessment in its widest context are making materials for the product from raw materials, such as the cement used to create the structure, manufacturing the product, such as the pumps, pipework, wiring, etc., used to create the MEP systems in the building, transport of the raw materials and final products, using the product, for example, emissions from the fuel consumed to heat, cool, light and power the building, and finally disposing of the product at the end of its useful life. Are the materials recycled or sent to landfill, for example? Just thinking briefly about each of these stages in the context of a building, it's clear that life cycle assessment is a vast process that includes both embodied carbon and operational carbon emissions. A building contains literally thousands or tens of thousands of components from different manufacturers. Judgments regarding the carbon footprint through the full life cycle of a product as complex as a building could vary significantly. Fortunately, international standards are being developed to help standardise processes and data sets. Let's now consider why LCA seems to be gaining traction so quickly in the construction sector, which it's worth, I think, reiterating itself is estimated to be responsible for around 40% of the global demand for raw materials. So until recently, LCA was seen as relatively difficult by the mainstream sustainability community. So it was largely undertaken by specialists and larger firms with bigger resources. A big part of the reason for that was the absence of embodied carbon data, meaning designers and consultants having to gather that data from individual manufacturers who themselves weren't really ready to provide it. Overall, it was a frustrating and time-consuming process. In recent years, LCA has become much easier via tools like DesignBuilder and One Click LCA, with their libraries of embodied carbon data. So those early barriers have now largely been removed. Secondly, the performance of the building fabric, HVAC, lighting, etc. has improved dramatically in recent years. And that has made embodied carbon a much higher proportion of the overall carbon footprint of the building. Third, the rapid advances in modelling tools such as DesignBuilder has made operational energy modelling, i.e. the energy consumed during building operation by heating, cooling, lighting, computers, etc., much faster and easier, giving modelers more time and headspace to tackle more progressive modelling activities. Finally, this improvement in modelling tools has occurred in parallel with ever-tightening energy and carbon emissions legislation in many countries, and also the introduction of LCA credits in environmental schemes such as LEED and BREEAM. That has resulted in far greater demand from a wider range of clients, whereas previously LCA demand may have been driven more by the public sector and major commercial developers. Hopefully you can see that all this presents a significant opportunity for you, as most of the data required for LCA is already included in the DesignBuilder model you create. So you can now extract even more value from the model by exporting the data to One Click LCA. We'll now review the DesignBuilder model from a recent project by 8 associates who are based in London. It's a relatively small and simple model, which is ideal for today's webinar, so we extend our thanks to 8 associates. 8 associates used DesignBuilder for the thermal and comfort design and regulatory compliance, and then exported the model data to One Click LCA to gain additional BREEAM LCA credits. The development will utilise a number of opportunities to cut embodied carbon, and based on a cost-benefit exercise has targeted all 6 credits available for the superstructure. The BREEAM pre-assessment for this building achieves a BREEAM Very Good rating. The project comprises of this 4-storey infill extension to provide additional office and storage space for the existing office building in London. You can see the surrounding existing condition buildings here, represented by the adiabatic blocks. And going to the ground floor, you can see it's a mixture of office and storage space. You can see all of the floors above represented by the wireframe outlines, and these are all office spaces. We'll now take a look at the DesignBuilder Constructions Library accessed from the Construction tab. The integration between DesignBuilder and One Click LCA works by mapping the material names specified in DesignBuilder to equivalent materials in the One Click LCA database. So provided you've defined your constructions using material layers and you've used appropriate generic material names, there's really nothing more that you need to do in DesignBuilder before loading your model to One Click LCA. Opening up this wall construction and then editing one of the materials, the data related to LCA is the name of the material here. The embodied carbon data on the embodied carbon tab here is only used within the inbuilt DesignBuilder analysis, which can be accessed from the cost and carbon tab at the bottom. Note that this data is not used within One Click LCA though. So before we look at the link with One Click LCA, I'd like to quickly show you the more basic embodied carbon analysis tools built into DesignBuilder. To run the inbuilt analysis, simply click on the cost and carbon tab. and then open the embodied carbon tab at the top. Then press the update toolbar icon and you can generate your embodied carbon report. So here's the report, and you can see that the embodied carbon is broken down by material and by construction, with a total for actual CO2 and equivalent CO2 at the bottom. One potentially very powerful application of these inbuilt calculations is to run whole life cycle optimization studies. This means that you can identify design solutions that simultaneously minimize LCC and LCA, for example. In other words, it enables us to minimize the overall lifetime environmental impact of the building while simultaneously minimizing the whole life cost. This sort of long-term assessment is likely to become more widely applied as intergovernmental policy starts to consider the long-term impact of buildings on our environment and economies. This slide shows the results of an optimization study where we were investigating the long-term cost and environmental impact of varying the number of PV panels amongst a variety of other things. As the number of PV panels is increased, you can see how the LCA is improved at the cost of LCC, i.e. they have an inverse relationship. Now back to One Click LCA. To start the analysis, simply click on this One Click LCA toolbar icon. This uploads the model to the One Click LCA website and starts the analysis. You've just seen that the DesignBuilder Materials library already includes embodied carbon data, so you might ask why you need One Click LCA. Well, this is because DesignBuilder's embodied carbon data is only really useful for general optimization, early stage LCA modeling. It doesn't comply with the more exacting requirements of LCA for LEED and BREEAM and similar schemes. One Click LCA is based on an extensive database of previously accredited materials, and DesignBuilder materials are automatically mapped to One Click LCA equivalents when the model is imported. This means in practice that whatever DesignBuilder library data you use in your model, that will be read into One Click LCA and mapped to their accredited materials automatically. I'll now hand you over to Panu, who will talk you through the process within One Click LCA.
So hello, this is Panu Pasanen from Bionova. I think you need to hand me the presenter rights as well. All right. Good. Yes, so my name is Panu Pasanen. I'm from One Click LCA, and I talk you through how One Click LCA works, more from a commercial application point of view, such as LEED or BREEAM. Then if you have any questions on other applications, you can ask them in the chat window, and we'll go through those in the end. First, a few words about One Click LCA, what it is and what you do with it. So One Click LCA is a global lifecycle metrics software platform. It's not one software. It's a platform on which we have about 130 different applications serving analysis fulfilling compliance criteria of certain credits or regulations, including any version of BREEAM there is in the world, all versions of LEED, and so forth. We also have modules for infrastructure, which are not in the scope of this discussion here, and for some other special applications, All of this revolves around lifecycle performance of the built environment, so lifecycle assessment, lifecycle costing, and carbon analysis. We are the global leader in this industry, and we are in business since 2001. And the whole point of this exercise, from our point of view, is to make it as easy as possible so that you have time to improve the design. The calculation should not be where you invest your energy. The thinking about improvements and working with your client to make them happen is what we want to give you time to do. So that's why we build all this automation and why we are very happy about this DesignBuilder integration. We work with companies in about 55, 57 countries probably, or something like this. Here are some of them. We are working in mostly all advanced economies, plus quite a few others, including with some of the leading institutions like governments and BRE and other organizations like this. The particularity of our platform approach is that we don't provide a single tool, we provide a menu of tools basically, from which you then pick the tool that you need for certain application. So if you work in US context, you probably would work with LEED or Green Globes eventually, or Living Building Challenge. Now also with the Zero certification. However, if you work in Canada, you might also work with the Zero Carbon certification by Canada Green Building Council. If you work in Spain, you could work with BREEAM Spain, Verde. If you work in the UK, you would work with BREEAM, undoubtedly, eventually Home Quality Mark and others. We have tools for all of these and many more on the platform. And the point is that you can always pick the ones which actually meet your requirements. The latest we added in the last 2 months is the Green Star for Australia and New Zealand. So we can support that as well. And then there's China and Singapore labels as well available. And in regards to data, it's extremely important to do the analysis with data that represents your region, because the technical standards and the performance and environmental performance of materials really vary. American concrete is quite different actually from European in this respect, and construction methodologies are different also in some parts of the world. So what we do is we integrate all the available data that meets our data quality criteria. Our data quality process has been approved by BRE. We basically feed the data into the platform constantly to make sure that you can choose from the qualified, up-to-date database to make assessments and actually consider also choices between actual products as opposed to generic profiles if you are at that point of design. So this is the list of the databases, and a full list can be found on the website. We do have generic data for the whole world as well. Now in regards DesignBuilder integration. So I will first talk you through the process to make sure the concepts are clear, and then I will show you how it works in practice. So starting with the concepts, very simple, press the button. It takes you to the One Click LCA login page, or if you already are logged in, it starts the import of the data automatically. When you import the data, it basically is a guided parametrable process. So you get to choose whether you want to have a BREEAM, whether you want to have a LEED, Green Star, or something else. And you can also adjust it with settings, including reviewing, filtering, and other things. The basic idea is that you just choose the right settings and you don't have to do too much. As it was already explained by David, the common standard labels in English as well as Spanish, as far as DesignBuilder is concerned, will be identified automatically. The same label, when you use it in a US context, will be assigned to a North American product, and when used in a UK context, will be assigned to UK product, and finally in continental Europe, yet to a continental European product. So there's context sensitivity in the data identification. However, you obviously need to introduce new labels. You will define something that you want to represent specifically. It's enough just to map it once. However, there's an exception. If you work with label things like default wall, they will have to be each time confirmed because the name is inherently ambiguous. So we prevent users from generating bogus results by accidentally defining a fixed meaning to a default wall. When you do whole building LCA, the important part is the whole, and energy model typically, I would say probably more exclusively than typically, is representing the zones. It's not useful to represent structural elements in our energy model, and energy modeling engines are not really good at doing 3D objects like columns or these type of things anyway. So what we allow you to do is to combine data. You could have a Revit model with the structures, or IFC model with the structures, or you could have a bill of quantities with the structures, and then you have your energy model. You can import both of them at once into the same project, and if neither of them has something, for example a foundation, you can add that by hand, or you can edit that by hand, and at the end you have everything. So you don't miss balconies just because it's not thermal. Well, balconies has shading effects, so maybe that was not a good example, but the staircase and elevator shaft, those are big massive structures, right? So you can just add them, no problem. You do it manually, you don't have to model it, because modeling it would be counterproductive and much more expensive in terms of modeling time than just by adding it for LCA purposes. You can also make the materials optioneering in the cloud, so you don't need to rework your data, and you also don't have to relabel your objects if you want to use a specific manufacturer data. So if your DesignBuilder model says mineral wool, for example, you can change that to a specific brand, or consider what would changing it to a specific brand mean without touching your model at all. So you can do this kind of optioneering in regards alternative materials or actual brand and product specification with using environmental product declarations. We come back to that in the demo part. This I think is quite important, because sometimes just specifying the best product in the market can help go quite far. Additional concept that we have that can support this is library of constructions. It's quite cumbersome to model a foundation if you don't have to do it for structural purposes. I mean, if you do it for LCA purposes. And we have a whole library, maybe a few hundred different constructions, which all allow you to simplify how you handle them. So if you just know, for example, what type of soil you have on the site and how deep is your bedrock, you can have a pretty good foundation simulation just by inputting the building area after you made the choice of the type of foundation. And of course you can expand that and edit that, so you will have the exact amounts of steel and concrete as relevant for your project if you happen to know exactly what it is. Right. So we are doing this now mainly for LEED first, but I will talk you through the few concepts relating to BREEAM. So the case project here actually is for BREEAM, but BREEAM has some specificities which are not really process specific, but more reporting specifics. So we do this maybe the easier way in the interest of time and making it useful for all attendees. And the case study, as it was explained, is a project courtesy of 8 associates from London. It's a project pursuing BREEAM UK, and what they do here in this context is to compare 4 superstructure options with different materials. That's the way BREEAM drives you to work, basically. And they have a clear strategy to reduce material impacts, and the LCA is of course feeding back into the material strategy. I'm not going to read all of this through, but this will help to instruct the choice of low impact materials and hopefully also materials efficiency. They have preference for procuring products with higher recycled content. I'm going to show you how that's helped by the One Click LCA database and what other options it enables. I'm not going to go through all the credit tables. So those can be found on our website. So and the credits, they vary really by different schemes. So that's going to be then covered online. And now I'm going to open the DesignBuilder model. So in the model, you have seen that you have the constructions that have been defined. If you need to change anything here, you can, but the main idea is that most of the time you don't have to, because you can also change things online. When you send your model to One Click LCA, oops, it's opening on the other window. Need to move it here. The first choice is confirm the project. You, of course, could work on any number of projects. I'm going to override an existing calculation. I will stick with lead with international application as my standard, as my calculation method. When I choose lead, it will automatically apply data filtering based on lead, so it will not consider anything that's not useful or required for lead purposes, for example. If you want to adjust any settings, you can. For example, if you want to import multiple models into same calculation, you would check this one. Presently, it's not relevant for us to prevent it, so we will just continue. What the analysis does now, it filters out any data which is not relevant for the scope purposes that have been selected. In a zone model, everything is relevant for lead purposes, so nothing is filtered out, and the data is combined. You can see that from the 308 materials, we have 36 remaining, and we have the resulting data set is mapped to 35 materials out of 36. So almost everything is identified. You can see what the data points represent. You can just click on the question mark and see exactly what data we have in the platform, even to the point of checking if it's an EPD, what is the actual EPD. And of course, you can change it if you don't like the mapping, and you can see why it's identified. So for example, it's telling me that this is what I used to call, or that's what I have chosen to use for this material. And here I have some unidentified data. So I have here a data point, which is insulation lambda 0.4. So why it's not mapped is basically because it doesn't say anything about what type of insulation it is. So it could be pretty much anything, really, I think. But I'm not an energy modeler, but so don't hold it against me if I choose something not appropriate, but I will choose this one. So just let's say it's going to be good for these purposes. Of course, if you want to search with lambda, you could also search with that, but I think it's a synonym for something else. So I will just take a glass wool. All right. And the other option you have is that you decide later. So you can just import it as a placeholder and then disambiguate it later with the architect. Because sometimes you could have a material which is not something energy modeler should appoint. So you can just take it as a placeholder. But right now, I'm pretty confident we can deal with glass wool as our basis. I can save the mapping. It will be also saved automatically. And then if I continue, I will get my LCA out. All right. So this is our LCA for Lead International whole building lifecycle assessment. It's completed, literally. We also have a LCA checker integrated to the software, and it's checking whether the data is plausible. Not going to cover that right now, but just so if you want to check it, it will help you identify whether it's looking realistic. And if you scroll down, you can see where the impacts are coming from. You can see they are coming from horizontal and vertical structures. Not very surprising. You don't have foundations included yet in the building. You can see they are coming from insulations, concrete, bricks, and you can see even which individual materials they are coming from. And if you want to see if there would be a more sustainable material that you could use, you could actually consider each of them individually. And then there's a lot of more analytical information that helps you understand not just the global warming potential, but also the other environmental impacts and how they accumulate over the life cycle. And here we get into something else that's quite important, which is the life cycle perspective. So the software automatically will account for transportation impacts, maintenance and replacement impacts, and the end-of-life disposal impacts of every material based on the approved life cycle model. So you don't look just as the material as purchased, but you look rather the use of the material or the life cycle of a building. Because if you don't, the risk is, of course, that you might choose a material that requires, for example, more replacements or more maintenance than alternative material. And then we have some additional visualization. This is it in short, if you do it for LEED. If you do it for BREEAM, the main difference is that you will have to classify the data according to something which is called new rules of measurement. So it's going to meet the categories BRE asks you to document. I have here now the two calculations. I could report compliance both for LEED and BREEAM at once from this one calculation. But before we continue, let's think about the process. So you want to continue from this to report compliance for BREEAM or LEED, and you need to know how you go about that. And what we have built into the software is a workflow that sits alongside you here and helps you walk through the steps. It will explain you what's the compliance basis. It will explain you what is the compliance baseline strategies that you have to choose for LEED, for example, and how you do every single step of the way until the submission of the documentation. And if you have a LEED, it's there. If you have a BREEAM, it's all there. This will make sure that you don't have to be a LCA professional to do this. You just need to follow the steps, do what it says, and document the stuff, and you'll be good. Of course, there's a few steps to follow, but that's all in a day's work, I think. So I, of course, know those steps. And if you work with LEED, the steps include creating an optimized building from a baseline building. So now we're going to do just that. We are going to copy the baseline design into an optimized design. This will create a full and independent copy of the data set, so we can vary anything we like. Doesn't really matter what it is. We could, for example, go and let's see, if memory serves, I think we had XPS insulation causing quite a lot of impact, so we could go and look for the XPS insulation here. This is now our building materials query, where all the data can be found, and you can see what are the relative CO2 impacts over the life cycle of a building of the materials. And our XPS sits nicely here. We can see that it's having 14 tons of impacts, mostly arising from the production of material, which is pretty normal because it's very light material. And if we want to change it to something else, we could just click replace. Now, we do want to keep the filter on insulation, so we are going to have to replace it with another insulation. But we could replace it with completely different type of insulation. So I think we could stay in our glass wool theme, and I could actually see us trying to look for the lowest possible impact manufacturers. So I think I'm just going to be a bit lazy this time, so hopefully you're happy with this choice. I just replace it with another glass wool again from Knauf. They don't pay us anything, so don't worry about that. And if you want to review any of the parameters, you can find it all here. And we can just save it and wait for recalculation, and then we will see what's the overall building level impact. From memory, the XPS impact over the life cycle was about 14 tons CO2, so we should shortly be able to see what's the difference. Well, it's pretty substantial. We probably chose a bit too loose glass wool for meeting the insulation performance of the replaced XPS, so it's not really fair comparison yet, but in every case we went to the right direction. And the important thing is that you can do this in a number of iterations. So you can record your iterations. You don't have to do it just once and get everything right. You can do it as often as you need to until you get to the point where you have the desired optimization results achieved. And you will see how it's performing in all the impact categories required for LEED. If you're familiar with the reference guide from LEED or LEED manual, you will know that you need to reduce impacts by 10% in at least 3 categories, of which a global warming potential has to be 1. We could now review if we are on track to hit it. So we are opening our optimized design and compare to the baseline. And in fact, we would be able already to hit the basic credit just with this one material specification, maybe a bit overly optimistic one, but in every case, the point is that the comparison of materials can be done very rapidly. Now, if we consider a few other applications, before you could submit an actual project, you would have to make sure that you do have all the structural elements. Right now, we don't have foundations in our model, not modeled for thermal purposes ever. So what we are going to do is we are going to add the foundations, for example. And we are going to assume that this is on sitting on 10 meters of soil. And we could go with steel core piling or ground concrete piling, depending on what your location usually does. You just pick the one you think more relevant, and you will actually input here the building area. I think here we talked about 160 square meter extension area, so it's not very large, but it's very simple. And you will find the whole buildup of the materials here. So it's all modeled in detail, but just simplified for you as an input. If you want to change the buildup, you just unbundle it and continue editing with the actual quantities if you happen to have the foundation figures. Other things you can do is if you have to model, for example, external areas or building systems, you could just as well go on. For example, in BREEAM UK, you have a credit for analyzing core building services. So we could look at pumps. So we could look at circulating pumps. We could look at heat pumps of different types. And we could see what's the embodied impact of adding one heat pump and what's the life cycle impact if we consider it's going to last for 25 years. As you can see, everything is assigned automatically, also transport impact. So you don't have to do those things manually. And every analysis results into the same screen with similar outputs, and you can compare them as often as you find until you find the level of performance that you and your customer are both satisfied with. And when you are ready to submit, you will find different submission reports. For BREEAM, it's a bit different. For LEED, it's a bit different. The tools will always provide you the right kinds of reports. And as mentioned, there's an LCA checker allowing you to check whether the quality looks all right. And you can always get a list of all the data sources, including what standards they comply with, what is the third-party verification status, and so forth. So it's fully transparent and fully documented. This is, I think, enough to give a basic understanding of what's the One Click LCA workflow with some actual data. Then a few words about the other opportunities software provides. You don't always get into a project in the stage where you can do energy concepts. If you have a good project, you probably will get hired fairly early. We also have solutions for studying pre-shoebox materials impacts. That's called Carbon Designer. It's an add-on module we have. We have also Revit integration and some other integrations which allow you to combine structural and energy models. The database I have shown to some extent. And we also have a carbon benchmarking program, because for energy performance, you know what energy rating B means, you know what C means. For carbon, it's not that obvious. So we have developed our own, which is called Carbon Heroes Benchmark Program, which allows you to benchmark your project to, well, the market basically. Carbon Designer is purely web-based. It generates your shoebox, it generates you materials, profiles, and you can do a full LCA out of it. And very simple optioneering, not object of today, but it's all available. Embodied carbon benchmarks. We have a program for 1,000 buildings, and we are about halfway now. So we are trying to get another 500 buildings fully qualified into this data set before end of the next year. And we work with several green building councils from Italy, Netherlands, Ireland, Hungary, and Romania. And we are bringing some more on board as well. We have lifecycle costing, and we have lots of integrations. So if you happen to have different sets of data on your different projects, it will, you will get your job done no matter what. If you work with BREEAM, this is the software that's approved for every single BREEAM scheme, including also BREEAM Netherlands, BREEAM España, BREEAM North, Sweden, Germany, whatever, with maximum rating. We have different lead modules for North America and Europe, and international means you always have your local data, and the assessment is always done in accordance with the lead manual using the method for your region. If you like to try it, you can create your user account. If you want to activate the DesignBuilder integration, just book a 15-minute demo with somebody from our side to make sure you're up to date on how to use it, and don't get confused in case you wouldn't have any LCA background. Another thing we released today is the Embodied Carbon Review. That's a publication, so it's not directly related to this, but it will show you in a very clear and concrete way how embodied carbon is addressed in business in 100+ construction regulations and certifications globally. This is One Click LCA, at least a short introduction to it. My name is Panu Pasanen, and thank you.
Excellent. Thank you very much, Panu. That was a very interesting and useful overview. We hope you've seen from today's presentation that the sustainability and energy modelling community now have tools at their disposal to enable them to quickly, easily, and cost effectively meet the increasing market demand for lifecycle modelling, and also to make a meaningful contribution to climate change mitigation. Thanks to Panu for showing how easy it is to use the One Click LCA service today, and thanks again to 8 Associates for providing the model. Thanks also to you for listening. That's the end of our formal presentation, but we'll stay live for another few minutes to take any questions. There will be a brief pause now whilst we review the questions already submitted, and we'll start answering them shortly.